Here is the second video for Math 2-3 about the quadratic formula. This has more examples, and the examples are a little more advanced. We're going to look at the example y equals x squared minus x minus 3.75. The fact that this is a decimal means that the only way we know how to solve this is by using the quadratic formula. We start by identifying a, which is 1, b equals -1. It's really important that you get the negative in there, and c equals -3.75. The first part that we always find is the square root of b squared minus 4ac. This is the right thing to do both by the order of operations and the fact that it's the hardest part of the problem, so you get it out of the way early. There's also another reason that I'll get to in a minute. So we have the square root of -1 squared. Notice here that I'm putting parentheses around the -1. Whenever you square a negative, make sure that you use parentheses, otherwise you'll get the wrong answer. Minus 4 times the value of a is 1, so I'm not even going to write it because 1 times anything is just itself. -3.75. That gives us a value of, let's see, the square root of -1 times itself is 1, and -4 times -3.75 on the calculator gives me plus 15, which of course equals the square root of 16, which equals 4. Finding the other values of x, we need to use the quadratic formula, which is x equals -b over 2a plus, in this case, we know that it's 4 over 2a. And then we have to find x equals -b over 2a minus 4 over 2a. Let's plug our numbers into that. We know that b is -1, and the negative of a negative is a positive. So -b is +1, and a is 1, so 2 times a is 2. So we've got 1/2 plus 4/2, which is 5/2, which is 2.5. So there's one of our answers. The other one involves similar reasoning. -b over 2a we already decided is 1/2. And from this we're going to subtract 4/2, which gives us -3/2 or -1.5. So those are the two answers. And you could justify those answers by plugging them back into the original expression. You should do that every time so that you know that your answers are right. If you choose not to do that step, you're really taking your chances. It only takes a minute. The next example involves a special case that we're going to look at, where y equals x squared minus 2x plus 3. Again, we find a is 1, b is -2, and c equals 3. When we calculate the square root of b squared minus 4ac, which is always where we start, we're going to find something a little bit different with this one. So let's plug the numbers in. We've got -2 squared. Again, put the parentheses around the -2. Minus 4 times 1, so I'm not going to write in the 1, times 3. This equals, we know that -2 times itself is +4, and negative 4 times 3 is negative 12. And this equals the square root of negative 8. Uh-oh. You can't square a negative number. Sorry, you can't square root a negative number. You can square negative numbers all you want. You cannot square root any negative numbers. So we say now that we are done. And the answer is no solutions. This is seen algebraically, again, in these steps. If b squared minus 4ac turns out to be a negative number, there are no solutions. But to make sure that you didn't make a mistake, you should definitely check this on a graph. Examining the graph of this equation that we were talking about, x squared minus 2x plus 3, you should be able to see from the graph that there's no solution to this problem because there are no x-intercepts. This parabola never crosses the x-axis. We saw it because b squared minus 4ac was a negative number algebraically, but we can also see it graphically because the answer to the question, where does this parabola cross the x-axis? In other words, where is y equal to 0? The answer is never. There's no real solutions. These examples in both Part 1 and Part 2 for the quadratic formula should cover all of the basic situations. There are, of course, more to learn about the quadratic formula and quadratic equations in general. We'll get to some of that in semester 2. And for now, we're done.